Well, good morning, Austria. Good morning, Denmark. Good morning, Switzerland. And good evening, Japan. Welcome to our cross-market info session, Robotics in Healthcare. My name is Cosima Steiner. I'm the Commercial Counselor in Copenhagen and will also be your Master of Ceremony, if you will, for the next couple of hours. Robotics is swiftly changing what we once considered science fiction into reality, and medical robotics technologies are changing the healthcare sector as we speak. So the next couple of hours will provide you, the audience in Austria, with insights from 3 different robotics hotspots all over the world, Switzerland, Japan, and Denmark, with 3 expert speakers. And I would like to welcome them all, together with my colleagues, the commercial counselors in Tokyo and Zürich. The webinar language is English, because not all of the speakers are native German speakers, but I do hope that they do allow me to say a few words in German also. So ja, guten Morgen, meine sehr geehrten Damen und Herren. Cosima Steiner, mein Name, Wirtschaftsdelegierte in Kopenhagen. Einen schönen Campus-Vormittag wünsche ich Ihnen allen. Die Außenwirtschaft Austria ist Österreichs Internationalisierungsagentur, aber mit unseren über 110 Stützpunkten weltweit verfügen wir auch über ein Innovationsnetzwerk, das Sie mit Wissen, also mit Trends und Innovationswissen, mit Partnern und auch mit Unterstützung bei der Vermarktung ihrer Lösungen unterstützt. Das heißt, Ziel dieses Webinars Robotics in Healthcare ist es, Sie aus 3 Hotspots der Welt mit den neuesten Trends, mit den Entwicklungen und auch mit Prognosen und mit einem Hinweis, wie Sie als österreichisches Unternehmen diese Technologien nützen oder intensiver nutzen können, versorgen wird. Switching back to English, let's have a quick look at today's schedule. For the next 2 odd hours or so, we will focus on 3 different markets, starting with first Switzerland, then Japan, and finally Denmark, or to be more precise, with 3 different hotspots in those markets. Each of the markets will first start with a brief introduction by the commercial counselor, and a welcome, of course. Then there will be an expert presentation by the expert in the specific hotspot, and this will be followed by a brief Q&A on the specific presentation you just heard. And then for the last half hour or so, we'll also have the opportunity to have a more general Q&A, which you can, where you can address your questions to all 3 presenters. A little bit of housekeeping before we get started. First of all, I mentioned questions. You do have the possibility to post your questions. Just type them into the chat box. We will collect them, and I will try to address as many of them as possible in the brief Q&As and also in the Q&A session at the very end. If your question has not been addressed or is not being addressed during the webinar, we'll of course make sure that you get the answer later on. And this also, of course, you can also after the webinar contact us at any point in time. The webinar is being recorded on YouTube, or it's not being recorded on YouTube, it's being recorded, but it will later be available on YouTube, so you can watch it, re-watch it, recommend it, share it however often you like. And then finally, the presentations will, of course, also be made available to you. But that's from my side. I would like now to hand over to my colleague, the commercial counselor Manfred Schmidt in Zurich, and also welcome the expert speaker, Dr. Verena Klamroth from ETH Zürich, and who will be focusing on robot-based neurorehabilitation. Good morning and welcome.
Thank you, Cosima. Grüezi from Switzerland, grüezi from Zürich. Well, the Neue Zürcher Zeitung titled lately, Zürich, the capital of robotics. Well, even if the self-judgment is quite biased sometimes, but there is some truth in it. Why is that? Why is Zürich quite an interesting hotspot for robotics? I think the reason is, and you might confirm that, the reason is that there is a strong university base, mainly around the ETH University, where a high amount of master and PhD students are trained and develop a strong knowledge base, and there are some leading robotic experts in Zurich, like Professor Roland Siegwart with his autonomous system lab. Well, this strong university base means also that international digital main players like Google or Walt Disney or Facebook have set up a base in Zurich and have strong cooperation agreements with this university knowledge base. For instance, Tango was developed here. This is a technology platform enabling smartphones and other devices to orient itself in rooms without GPS. And this ecosystem has also led to quite a numerous amount of spin-off companies in the robotic fields which are located in Zurich. Well, as Cosima has said at the beginning, that we position ourselves also as a sort of bridge for Austrian companies to get access to these leading technology developers. The Federal Austrian Economic Chamber of Commerce, the Wirtschaftskammer Österreich, has signed a cooperation agreement lately with the ETH, with the intention to bring Austrian companies, to enable access for Austrian companies to these leading technology drivers. Having said that, I now may introduce to you Verena Klamroth, our expert today. She studied human medicine in Berlin and later on worked at the Institute of Human Genetics in Münster in Germany, and is now, I would say, one of the leading experts in the field of robotic neurorehabilitation. And you are working with the Institute of Robotics and Intelligent Systems at the ETH University, and at the same time, as you are a doctor, you are also at the University Hospital Belgrade, University of Zurich. And the quite interesting thing is, in Zurich, every 4 years, the Cybathlon is organized. Cybathlon is something like the Olympics, motoric competition for people with a handicap. The motoric competition allows the assistance of robotic devices. And the Cybathlon was held in Zurich, and like the Olympics, will be held every 4 years. But now it's on me to hand over to Verena Klamroth. She will inform us about the development in robotics in healthcare in Switzerland. Please.
Thank you for the very kind invitation and introduction. As it was said, I'm a medical doctor. I work at the Technical University, the ETH, and that is because I work at the Sensory Motor Systems Lab, which develops robots for healthcare. And the head of this lab is Professor Rina, who is an engineer, and he has a double affiliation. He's a professor at the ETH, but he's also a professor at the Medical University. And that's also that our lab has got 2 points where we work. We work at the technical part. We are also placed at the Balgrist campus. And Balgrist campus is very close to the Balgrist hospital. And it is a place where really interdisciplinary teams from all fields of medicine, engineering, biomechanics sit together in one building. And it shows somehow the interdisciplinarity we have in Zürich at the ETH and also in our lab. And I'm situated there, and we develop devices for neurorehabilitation mainly, so robotics. And the special thing about robots is it's machines, and they interact with the human. The human is not always predictable, and that's a challenge for the engineers. And we develop devices for neurorehabilitation, so that's people with brain injury, can be spinal cord injuries, so paralyzed people, but also stroke. So diseases which are very common nowadays and need very long, lifelong treatment. When you look back, devices to be used in medicine is not something new. You see here a picture which is nearly 100 years old from the Balgas clinic, and you see here already children who are lying on devices. The term orthopedics means authors and pedis, so stretching children, and that's what they did back then. They used devices and thought that that would be a helpful therapy. There are also exoskeletons, devices which are now very much in common again. So devices which improve the walking of people. This is back from 1890. And nowadays, of course, we have more sophisticated devices, and we can roughly distinguish in neurorehabilitation devices for therapy. So the patient is in the clinic or at home and trains with the device. And we can distinguish it from assistant devices, for example, prosthesis, but also exoskeletons, we will hear later in a talk from Japan, that assist in daily life to walk. And I want to focus first on devices for therapy. You see here on this picture on the left, known explicitly developed for rehabilitation. It's an end effector, that means it's fixed at one point of the body, here in the front at the hand, and it's back from 1990. And here already people could train after stroke mainly in virtual reality, so on a graphical display of the monitor, games in virtual reality. And here it's about reaching points. So this is an end effector. We distinguish roughly end effectors where the device is fixed on one point from exoskeletons where the device is fixed on several points. And well known for this are exoskeletons for walking. And you see here on this slide several devices. On the left, you see exoskeletons that really surround the leg. You must imagine when you had a stroke or spinal cord injury, it's you have balance problems, you're weak, and it's very hard for the therapist to train with you the walking. So you need 2 or 3 therapists to really guide each leg and the trunk through the movement. And these devices have all the same principle. They surround the leg like a scaffold, fix the person, the weight is held by a harness from a bus, and then they walk on a treadmill. And then on the right, you see 3 devices which are end effectors. So the people are not in exoskeletons, but they stand on foot plates, and the foot plates move them. And on the lower right, the haptic water, it's more for research, but this is really even able to simulate walking stairs or even disturbing the walking so that people stumble. And this is a very good option to train the highly repetitive walking that we do in a high repetition, so hundreds, thousands of times with these devices. Now, robots is not only about enabling to walk, but they can also bring some motivation into the training. You see here a video of a young man who is walking in an exoskeleton robot, the Locomat, which is from a company here in Switzerland, from Volketswil. You might not see the video, but I think you can also see on the picture, on his whole posture, that it is not so motivating. Walking is monotonous. Walking is putting one bag next to the other. But yeah, in such a machine, it can be a little bit monotonous. So what we also work on, we don't only work on the robots, but we also work on the way we present the task to the people. And we are developing virtual realities that interact with the human. And there's also, again, a movie on the next slide. Here, and this is a scenario somebody sees on the huge screen while he walks in the Locomat. And you see we can adapt the surrounding. Now there's rain. If there wasn't sound, you could hear the thunderstorm, the flashes coming. Then the whole situation can become a little bit more scary while they have to walk through a narrow bridge, for example. And this scenario can even interact with the human. So when the device realizes that the person is slacking, is not putting too much effort, it can adapt the scenery to the person. And then you can also add things like, for example, stones, which don't really exist on the device, but the device can give this feedback that you stumble through a stone, for example. And then this is a device for adults, but we also have devices for children. Sorry, this is the next one here. And there's also a little video. This is a Locomat for children. This was a collaboration with the Children's Hospital in Erfahren in Switzerland, together with the company Hokoma and ZHDK. So students here developed movies. And again, it's a scenario only for children. So the child is walking on a soccer field and interacts with others. It even competes with this other little human in virtual reality who is faster to catch the ball. And again, it's interacting and reacting to the abilities of the person who's playing. So it's not just a movie which is running. And these are examples for the lower extremity. I want to go to the next slide. I work also on the upper extremity, so arms and leg training. And what you have seen here, for the legs, was very much for spinal cord injury, but also for stroke, but it was always in both legs because we can walk only with both legs. You see here the army robot that was developed at ETH together with the Bulgars. And this is a robot where one arm is fixed into the device, and it has got the same degrees of freedom that the arm has functioning. So you can move the shoulder, you can elevate the arm, retract, abduct, adduct, you can rotate the shoulder, you have elbow flexion and extension, the wrist can be moved, and also hand opening and closing. And it's also an exoskeleton, and the principle is similar what you saw earlier. So here again, a little movie to show you how these devices interact. This is a typical ticket machine to buy a ticket for the train in Zürich. And the person has to perform this task in virtual reality, takes the money and puts it into the machine. And this is a robot. So the machine realizes when the person is not able to perform the task alone. And only then the machine assists. So we call it assistance as needed. And behind this is, of course, a complex control strategy, which is challenging for the engineers. We train games. Patients can do games like catching balls. They get feedback, how good they perform. They get points. But also important for rehabilitation is to perform tasks of daily living, activities of daily living. We call it ADL. And we work very close together with hospitals. And that is very important, that the development is not technology driven, but really patient driven. What is needed by the people who use the devices later. So together with therapists, we thought about tasks we would like to train with people which are relevant for daily life. And you see on the lower bottom of the slide some examples, like it's in the bathroom about brushing teeth. It's about in the kitchen, frying meat in a pan, cutting bread, pouring wine into a glass. The ticket machine I showed you, or also playing piano with the hand. And we had 20 ADL tasks, 9 of them we realized in the device. And then you must imagine patients come to the clinic, they are sitting in the device, and then they perform these tasks. And it's like a therapy with the therapist. It doesn't replace the therapist, it's rather like a tool for the therapist. And we tested this on patients after stroke. Stroke is very common. 1 in 6 people worldwide suffers from stroke. The medicine becomes better and better, so more people survive the stroke and more people have to cope with the long-term disabilities, consequences from the stroke. And about 80% of people after stroke suffer from hemiparesis, so weakness in the leg, arms, and the face. And we did a study in patients after stroke where we compared the therapy with this robot, with the Armin robot, to the conventional therapy, so physical and occupational therapy. And you see here on the slide the result. The patients had 8 weeks of therapy, in total 24 hours, and it's with the gray background, you see these 8 weeks, and the black line is the result of the patients in the Armin robot, and the gray line is conventional therapy. And what you see is that the patients in the Armin robot gained more motor function than the patients with the conventional therapy. And what you also see, after 4 weeks, the robotic group gained the same gains, 2.6 points, while the conventional group needed 8 weeks. So in double the time, the same result. and a better result after these 8 weeks. Now, I must say that made us very happy that a robot is not only as good as the therapy that we have nowadays, but even better. But I must say this is also a lot about statistics. And these points you see, this Fugl-Meyer score, which tested that was not so relevant for the individual patient, the result. It was good, but we want more. So we keep on going. We keep on improving these devices. What was also a very important result for the patients was that when we look at, we have people who are more severely affected, people who are less affected, and when we look only at the more severely affected patients, and that you see on the next slide, they really showed a difference in comparison to the conventional group, which was, that was a little bit, thank you. The conventional group had very little gains when you look only at the most severely affected people. And that is really important because we don't have an effective therapy after stroke when it's really severe. And we had that with the robot. That made the difference. Here you see also this arming robot for children. So like the Locomotive is a children version. We have also a version for children. The design from the hardware from the robot is a little bit different. And we have, of course, also games which are specifically for children, and the safety is a little bit different. So I said we improved the device. You see here another video again. I want to highlight here how transparent the device is. That means you must imagine that this metal arm weighs a lot, about 20 kilograms. And we want the user, while he uses this device, not to feel this 20 kilograms. So that requires, again, the engineers to make it transparent, and how you could see that the person could really well move both arms, and it was nearly hardly as if the device wasn't even there, while he does really fast movements with the robot. We have developed this robot. The robot interacts with a human, with one human, with the patient, but we can do more. We can do that several robots with several people interact with each other. And that's what I will talk now about. When patients sit in this robot and train, they train like when we do on a computer game, but they could also play together a game, both sitting in a robot, both playing a game, but with each other, against each other. And we tested this multiplayer scenario. You see in the upper right, this game, the air hockey, and we tested patients after stroke and healthy people, what they prefer. Do you prefer to play alone on the robot? Do you prefer to play against somebody else in the same game? Or would you like to play with somebody together against the robot? And as I said, we tested it in patients and healthy people, and we paired them together, and everybody tried this. And what we saw was that both healthy people and people after stroke really enjoy this playing together with the device, and they especially prefer to play against each other. It depends a little bit on the personality. We also tested on personality questionnaires how the people fit. So you see here in one robot sits a therapist, a young woman, and in front sits a patient, and they both sit in a robot. And now these two robots are connected. And one of the persons can be the master, and one of the persons can be what we call the slave. So one guides the other. So the therapist here in this example sits in the same room, but he could somewhere else, in another room, somewhere else in the world, in his robot. And when he moves the robot arm, the patient arm is synchronized and is also moved. But the two devices interact. So when the patient, for example, has a spasticity, he puts resistance to the movement of the therapist. And now the therapist can feel this spasticity through the reluctance of the device in his own arm. And this is something completely new, that the therapist really feels the disease of the patient in his arm. It is a new experience for the therapist as a teaching, but it also enables him to assess the patient, to assess the spasticity, to assess the weakness of the muscles, because the patient can also be the master, guide the robot of the therapist, and then the therapist feels, oh, there's a very small range of motion. Here he becomes weak, he can't move in this area. And because it's such a new experience, we call it the beam me in, because it is as if the therapist is beamed into the patient. And then I have another example. Now we have a robot, a patient, and a therapist. And the profession of the therapist changes with the device, because so far the therapist guides the arm of the patient, is directly connected to the patient, puts his expertise and his handling into the therapy while he moves the patient. Now with robots, he has to steer a device, he has to control a device. The device has the advantage that it can move the arm highly repetitive. The weight of the arm is not a problem. He can do hundreds of repetitions in an hour. He can relieve the therapist through this, but the usability of the device is difficult for the therapist. So what we did is we used the arm robot, and you see that on the next slide. And here is a little video again that was already shown earlier. We put handles on the robot for the therapist. So the device knows now that the therapist is moving. And the device can learn from the expertise of the therapist what should be done. So here in this example, the therapist gives a path. Now the patient has to move his arm within this path. The device learned it from the therapist, keeps the patient there, but the therapist can do more. The therapist can show the device, here you must give support. Here the patient is strong, we will even resist a little bit. And the device learns it from the therapist, puts it into therapy, into action, but not only replays what the therapist showed, but still adapts it. So the device realizes, oh, the patient becomes more fatigued over time, I must support now a little bit more, but still applies the principle that the therapist gave to the device. So I spoke now a lot about therapy devices, but I said there are also assistive devices. I will give you only one example. It's not about a prosthesis, but it's about exoskeletons. We will hear later a very interesting talk about Rewalk. That is an exoskeleton that supports people, for example, of the spinal cord injury, mainly, we will hear that later, in daily life. So it's not only for therapy, so that people can get out of the wheelchair and walk again, but they can also use it in daily life. And this is very important for people after complete or very severe paralysis of the legs. These devices have the advantage that they give very strong support. They can keep the whole body weight of a person. They can help to move the legs and allow even stair climbings nowadays. But if we imagine it in daily life, this is really for severely affected people, because the devices are, of course, still have their weight. They still interact with the human, so you can feel them while you walk, and they must really fit well to your legs. They are bulky, and they can interact with the environment. But not all people need this very strong support. We have many people who are elder, who just have a disease which makes them weak, which puts them perhaps even to the wheelchair, but they can walk some steps when they have support. And that's why I have this picture here. So imagine you want to go to the bakery, you go there with the wheelchair, and now there are some steps, 3 steps. You can't do them alone, you can't climb them with the wheelchair, and you would need a little support. And for that, we have a new invention which is called soft exoskeletons. So, see, next slide. These are supposed to be worn under your clothes, so they are not rigid, they are not metal structures, but made of stripes, ribbon, and they kind of imitate their own muscles. And they have motors which move the legs, and you can use them as a support for short routes of walking. And you see here, this is a startup, an example of a startup from ETH, where 2 students who invented this device now want to bring it on the market. And before I finish about my talk, I want to give you a little outlook on what we imagine how therapy will be in the future. We will meet the therapists. There will be one-to-one sessions with the therapist. It's very important for the recovery, but we will add robots much more. And the idea is that we have 724 rehab gyms, like fitness studios, where we go for fitness training, where several devices stand. There's the therapist supervising it. The patients not only train 1 hour, but as long as they want. They play virtual games. And now comes in what comes in many topics nowadays, big data. We want to collect data from many patients from all over the world. We want to observe them. We want to observe the recovery. And based on the experience of all these people, we want to create tools which allow the robot to adapt constantly from the beginning of the disease over many years, a therapy concept based on the information we got from all the people. So I want to close with this of my talk. I just want to thank all the many PhD students who realized all the topics of the arming robot I presented to you, and Professor Robert Wiener, who's the head of my lab.
Thank you very much, Dr. Klamroth. We now have about actually almost 10 minutes for questions and answers that have come in via our chat box. You elaborated already a little bit during the last 3 minutes or so on the question one of the questions that was posed, which reads, will the rehabilitation therapy with robots replace common physiotherapy?
Yeah, no, for sure not. We need this one-to-one. What we want to add to the therapy we have now is that patients can train more, that they also, I only showed you a short picture only of devices at home, but the idea is also that at the clinic, but we want patients also to have devices at home, telerehabilitation, that they can use their time at home, many hours training alone, again with devices which are connected to the therapist. So the therapist can supervise from remote the home training. We want people really to train 4 or 5 hours a day if they can. We want them to intensify everything. And this intensity is very intense for the therapist, and our society can't afford it. It would be too expensive. So we add this to the therapy. But we should never underestimate the expertise of a therapist who has a very good handling with patients, very much feels the needs of the person. The devices are not there yet. And we should not underestimate neither the importance of human interaction, which can't be replaced by devices, never.
Yeah, thank you. Next question was, what are the challenges of bringing your advancements in research into a complex real-life setting and into a real-time environment? If you could share your experience with that.
You mean could you repeat it? You mean how we bring it to clinics?
Yeah, exactly. That's how I read the question that was being posed. But the challenge of bringing an advancement from a research setting into real-life, real-time environment. And what are your experiences?
Yeah, this is not only research, what I showed you. There are several companies all over the world developing many devices. We hear later about the Rewalk. I mentioned Hokoma here in Zürich. Tyromotion in Austria is very successful. And they sell many of these devices, mainly to clinics. And there are in the clinics already these setups that several devices are used by people. Very important in everything which is developed is user-friendliness. And I think this is still a challenge, that these devices to set up, to put a patient into the device and start the therapy can be still demanding. But it's getting better and better and more optimized also. And we're working on that.
Thank you. Yeah. Third question: how can Austrian institutions or SMEs cooperate or do research with you or with the ETH? And what kind of requirements have to be met?
They're not. We are already working international. There are very many research cooperations through Europe. We also work together with clinics in Germany, not only in Switzerland, and it's always important, as I said in the beginning, that clinics are involved during the whole development process, not only at the end. And that's what we try with clinics here in Zürich, but all over Europe and all over the world, to also meet the needs of different societies that can be also international, also when we take into consideration costs, also in countries with less money. So we try to enable this technology worldwide, really.
Thank you. Maybe let's take a final question. What is the reason for the exceptional position of Switzerland, or specifically Zurich, in the field of robotics? Is it the ETH that pushes it so much forward, or?
Yeah, it's for sure very important part is the ETH. It's a very good university, leading in the world, in the leading universities, especially in engineering. But there come more factors. It's also, of course, a very nice surrounding. You don't see the view I have now in the lab, in the office here. We look at the Zürich Lake. Switzerland has very high life quality, but it's not, that's only a soft factor. Important is also the high quality medicine. A lot of research is successful in Switzerland in medicine. Professor Martin Schwab is a very good example who does science in neuroscience, basic research in neuroscience. We all work together, and I think that is an important factor, that we have this very near environment with the university. And at the Technical University and the University of Zurich, this medicine is close by and working together a lot.
Mm-hmm. Well, thank you very much, Dr. Klamroth-Marganska. You will join us a little bit later after the third presentation. But now I would like to say good evening again to my dear colleagues in Japan, the Commercial Councillor Ingemar Lochschmidt, Technology Officer Marcel Rasinger, and then please do apologize my pronunciation, Mr. Yutara Naito from Yaskawa Electric Corporation. It is quite late, I think even for Japanese standards, it's almost after office hours, but I very much look forward to your presentation.
Thank you. Good evening, ladies and gentlemen. Good evening from Tokyo, Japan. We're here at the offices of Advantage Austria, Tokyo. I'm here with, my name is Ingemar Lochschmidt. I'm the Austrian Trade Commissioner here and head of Advantage Austria. We have here Marcel Rasinger-san. He is our technology man, your man for technology here in Japan. And we have a very special guest here, Naito-san, who has just been introduced. From a leading robotics manufacturer, Yaskawa, and well, he knows very much about exactly this subject because he's also a therapist, and so he's exactly the man to talk about the products which he will introduce today. Now we've heard that in Zürich was dubbed the capital of robotics. Well, I think we could dub Japan as the country of robotics. We have just finished a couple of days ago another mission of Austrian companies coming here on one of the trips to Japan, where we showed them a number of robotics manufacturers and also companies and institutions where robotics are actually being used. And the feedback was once again, well, this is definitely the country of robotics. And why is this the case? Well, Japan and Japanese people just love machines. I've been here for a year and a half, and I can see anywhere, you see machines everywhere, you see robots everywhere, you see factories which are almost without people, without workers there, all manufactured by robots. And I would say the Japanese have a very positive attitude toward robotics and towards machines. But we will hear that a bit later. I would just want to encourage you, also next year, 2018, we plan to do another trip here to Japan on the mission for robotics, probably this time not for this kind of robotics for healthcare, which we talk about today, but for other kinds of robots, for industry automation more than anything. And there are many, many fields where Japan is really at the forefront of robotics. So please do come to Japan in order to learn something about robotics here, but also in order to sell your technology and to do joint development. This is what we're here for at Advantage Austria Tokyo. The same way as all our other Advantage Austria offices around the world. And we have especially here Marcel Rasinger, whose task is here to help you exactly with technology, with innovation, with these contexts. So I would like to hand over the microphone to Marcel and to Naito-san here. Have a great webinar. Thank you.
Thank you very much. I would like to directly dive into my presentation. Yes, so actually, as you know, Japan is a shrinking population. So the problem the Japanese government is facing is that they have to find solutions. And one of the main pillars to solve this problem in Japan is to use robots. That's why in 2015, Prime Minister Abe started the Robot Revolution Initiative. So this is an organization to facilitate the communication between the private companies, the government, and education and universities. So also the Japanese government has a 5-year plan to accelerate technology innovation and also development in this field. And from 2015 to 2020, they have a new plan. They call it the Society 5.0. And the Society 5.0, I will explain in the next slide. It is strongly supported by the key technologies, IoT, AI, big data, and of course, we're talking about robots. So next slide, please. Maybe we have a little bit of latency. Sorry for that because of the distance. And so what you see in this slide is just to illustrate a little bit what is the difference between the information society we have now and also the Society 5.0. When you see on the left-hand side, you have actually our society now gathering data from the internet or clouds. And with the example of robots, robots are still supervised by human and get data from the internet and are controlled. But when you switch to Society 5.0, where Japan is now heading, actually it is a lot of big data already in combination with artificial intelligence that the human only get already filtered high quality information to make a better decision. So also when you see in the robot field, actually the robots are very autonomous and produce by themselves. So, oops, this was a little bit too fast. So actually the 3 pillars of the Japanese government or the goals are, yes, thank you, are actually to become the center in the world. So that Japan is the center of robot innovation, and also to make Japan the country where you have the most best cases or practices where people around the world can come to Japan and see how you can integrate robot into society. The third one is actually through the connection of all robots, we will also gather a lot of information and big data. And the important thing is to have high quality data gathered. So actually the Japanese government will also look into establishing laws and mechanisms to encourage private companies to invest more in the development of robots. So it will be until 2020, it's estimated to have a market of approximately 750 million euros. So in the field of healthcare, until 2020, especially at the nursing care, this market should grow to a market of 375 million euro. And also until 2020, the government wants to initiate 100 robot projects in the medical device industry. And now I'm getting to the end of my part. And actually, you know that 2020, there will be the Olympic Games. And also in Japan, to promote to the world that Japan is very active in the robotics, they want to initiate they want to exhibit the Robot World Summit. It's like the Olympic Games for robots. So thank you for listening. I will pass over to Mr. Naito.
Hello, everyone. I'm so happy to join today. And thanks so much for attending this presentation. My name is Yutaro Naito, and I'm in charge of healthcare marketing at Yasukawa Electric Corporation, Japan. Today, I'd like to talk to you about our products. There are 3 things I'd like to cover today. Firstly, I will quickly introduce our company overview. And then I will talk about working assisted robot named rework. Finally, I will quickly describe our original device named anchor assisted device. Okay, so let's move on to the next slide. In the first slide, I'd like to start by looking at general company overview. So Yasukawa Electric Corporation was founded in 1915. So originally, the company made electric motors for coal mining. And the company shifted our focus on mechatronics field, like AC sub-motor system and the industrial robots are used in the automation factory. So now some applications of motors and the electric system are in the market. So in the long-term vision for 2025 as a manufacturing company, we now expand our fields to humatronics field and the clean power market. Today, I'd like to introduce our two devices in this humatronics field. So at first, let me explain working assisted robot named rework, made of Israel. So this is a rework. It's a bionic system which allows people suffering from the paralysis of their lower leg to sit and work and stand up. So generally often be called exoskeleton robot. Using the work to change their life and improve their quality of life. The picture has shown achievements in London Paralympics. She was a flame bearer and completed the full marathon for totally 17 days in London. This device is made of robotics in Israel. In Japan, it is not medical device according to the government regulation. So let's move on to the next slide. Movie.
We'll show a new movie. Let's have a try. I'm sharing the screen. Hopefully everybody can.
Yeah, let me show you the device. These real SCI patient, whether injury would be L1. He completed official training in the hospital for about 40 hours. Finished training up, we Yasukawa actually issue a license to each. In this slide, I'd like to show you main components of the rework. Let me explain 5 main components. Next page. Yeah, sorry. Oh, sorry. So the first one, backpack contains lithium battery and onboard computer, which contains our radio transmitter to communicate with backpack and remote communicator like watch. The watch has a button that allows the user to select whether they would like to sit, stand, and walk. And the tip sensor worn in a pelvic brace on the left side of the body. It propels the body forward by detecting a slight shift in balance and body weight. And then exoskeleton supports body weight. And crutches give the user balance as they lean forward. This is the all components of the rework. Okay, let's move on to the next slide. Generally speaking, SCI patients spend daily life in a wheelchair for a long time. they need physical activity to keep their healthy. Walking seems to keep their healthy. And let me show you some information of influence for SCI health in this slide. So clinical studies show that standing and ambulation in the work provides potential health benefits as well. Reduction of some medication and improved bowel and bladder function and improve mental health and improve sleep and reduce fatigue and decrease body fat and pain. So finally, improve posture and balance. So most of the SCI patients return to community. This data supports rewarding change their physical activity. Maybe this device, maybe the device which can shift or solve the issue with their physical health. Anyway, people can spread possibility of working of SCI patient. User can transfer to the reward, like a picture at upper left. And also, the user will be lectured how to use the device, like a picture at the lower left. Then, the user can achieve working with the device throughout lecture and training. The reward provides new approach in the rehabilitation field. And two ways, both personal use and clinical use in a hospital, clinic, and so on. So in addition to reward, we have original device made of yes power in this market. So called ankle assist device for stroke patients. Let me explain from next slide. As I said, this device mainly focuses on stroke patients. They are often paralyzed and have gait disorder. Especially, it is difficult for the physiotherapist to manual approach to the human ankle while walking in the clinical field. The device can directly approach to patients, those who have paralysis of their ankle. Of course, the device is handy and easily used in a clinical field by the therapist. So as you see, based on the pressure sensor in a sole, in a shoe, this device assists plantar and the dorsiflexion of ankle movement. We expect some influence as indicated in the slide by using the device. Yeah, please look at this promotional movie I made. So firstly, therapists can easily put the device onto the patient, like short leg brace. And then specific controller is available to arrange the ankle degree, torque for assist, and gait cycle. Pressure sensor monitor the gait phase while patient walk. Yeah, it is the motor assisted brace, simply saying. mainly focus on the stroke patients. Okay, finally, so thanks much for your attention. We continue to develop the healthcare device in this market. I introduced 2 devices this presentation. If you have any questions and comments, please let me know in the Q&A session.
Are there any cooperations already with the hospital?
Yeah, of course. There are 2 main hospitals in Japan. Mm-hmm. So the first one is West Japan, and the other centers are in the prefecture close to Tokio.
Okay, so I think one of the guests wants also to know, so is there also any possibility to get the part of the cost refunded by insurance companies?
It is not available in Japanese market, but the other markets like Europe and the United States, they often take some insurance as a payment for the SCA patient.
So let me see, there's another one. So it's interesting that actually Yaskawa is manufactured by themselves, but what was crucial that Yaskawa actually chose to work with a foreign company.
Yaskawa, we are always looking for the synergy with core technology, our core technology like motion control and robots. And also, of course, we need social impact.
So maybe one last question is possible within the time. How much does the device cost? Maybe that's also a question people are interested in.
Maybe in the Europe market, 95,000 euros. So
95,000 euros.
So I think it may be so expensive for the personal user. In the market, often the insurance system and the model has changed from the Japanese market.
Is there also a possibility to, some business model like rental?
We have one is the sell out to the patient or clinic, and other one is the leasing system. Just
how much would that be, like monthly? Is there any?
Monthly, 5 months.
Okay. How much do you pay monthly?
About $20.
$20. That's sorry, again.
$20,000.
$20,000. Okay. So thanks a lot. I think there are no further questions from the audience. So we would like to pass on to Cosima.
Thank you very much, Marcel, and arigato, Mr. Naito. I would like to apologize to the audience for some technical difficulties we had, and also we had some comments that the tone was not ideal. I hope it's going to get a bit better now. Unfortunately, also due to these technical difficulties, our Japanese colleagues won't be able to join us for the Q&A after Denmark. However, we did receive some further questions here on the chat, and we'll make sure to address them later on to our colleagues in Tokyo, and you will definitely get an answer to that. So thank you very much. Moving on to the last country, Denmark. First, a brief introduction by, in fact, myself. You know me by now, Cosima Steiner. And later on, Klaus Rieseyer from Blue Ocean Robotics will give his expert presentation. Just from my side, I received a comment in the very beginning, or we all did receive a comment in the very beginning from one of the viewers. Alles klar, wir sind schon gespannt auf Japan und die Schweiz, which means for you, Klaus, great, we're looking forward to Japan and Switzerland. And you know, this of course puts a knife through my heart. Where is Denmark? We're here to change this a little bit and to talk a bit more about the Danish robotics competence. Because Denmark might, of course, be known to you as the country of little brick toys, or maybe also logistics, transport, pharmaceuticals, or probably beer. But in fact, Odense, Denmark's third biggest city, is not only the birthplace of Hans Christian Andersen, but also a major robotics hub, and always cited among the top 10 robotics ecosystems in the world. Denmark has a good predisposition for technological advancements. It is regularly cited as an innovation leader on the European Innovation Scoreboard. It's Europe's most digital nation, and it has a substantial robotics base that's also already tracing back a couple of decades, actually, with world-class manufacturers, academic programs, and research institutes. And Denmark is always very prone for collaboration and follows a triple helix approach, where public institutions work very closely together with R&D and education, and also with companies and startups. And you see this very clearly in the Odense robotics cluster. Danes are, generally speaking, a curious bunch. They are early adopters, and according to Eurobarometer, also have a general openness towards robotics. And if you look at this ratio of number of devices installed to 10,000 employees, Denmark currently ranks 7th place internationally, so among the most robotized countries. And also being a small open economy, always open for international collaboration. Denmark has several centers of competence for robotics because it's a major field the country is focusing on. But the biggest one is certainly the Odense robotics cluster. This little article you see on the right of the slide was just from yesterday's daily newspaper. It's a big article on the competence of this robotics cluster in Odense. It has over 100 companies that are internationally active. The crown jewel is probably Universal Robots with its cobots. They have been bought 2 years ago by an American company. I think they are probably the most known, but there are many more. They have over 10 world-class research facilities and over 40 robot-related education programs. The initial investment, or I say initial thrive for this robotics cluster in Odense actually came from industry with a very substantial investment by Maersk into one of the research centers with a specific focus on advancing the robot technology. And yeah, you see the strong growth in robotics over the last few years. The number of employees in the robotics cluster increased from 1,800 to 2,600 and is further increasing. But that's enough from my side. I'm welcoming now Klaus Rieseyer from Blue Ocean Robotics. He's the co-founder, co-owner, co-CEO. Blue Ocean Robotics is a company specialized in creating and commercializing robots, and it works to commercialize cutting-edge academic projects by connecting researchers with global business. And Klaus' presentation will focus on the disruption and the future robotics will trigger in today's healthcare sector. So welcome, Klaus, and we all look forward to your presentation.
Thank you so much. Thank you for introducing me. And let me see if I can switch the slide here. Okay, so that's already an introduction of me, so let me skip that. I was part of the team starting up in 1988, working with the shipyard to start the whole cluster here. And the next slide is really showing the entire community here. And as was introduced here, we are more than today 120 companies. And what you see in the middle to the right, you actually see the investment community, and in 2016 we reached more than 100 million euro that was invested into these companies. This year we reached 100 million euro already by August, September. And to the left of Odense Robotics in the middle, you see a whole community of labor unions, employer organizations, clusters, and so on that are really supporting the whole robotics community. And all the organizations you see in the bottom, they are really educational institutes and universities, and they all have robotic programs. So this is really a growing cluster. And just in this small city, which has around 200,000 people, there are more than 3,000 jobs directly into the robotics industry, and even more jobs in the companies that are supplying the robotics industry with components and so on. And so let me move on. I have two big topics to present to you today. The first big topic is all about the exponential growth that we see in the robotics industry. It's the fastest growing industry in the world with a double exponential growth. And there are some disruptions that are coming with this. And I would like to just briefly touch upon this. That's the first topic. And the second topic will be showing you, I think, 7 examples of robots in the healthcare sector that we at Blue Ocean Robotics have been working on and are introducing in the market these days. So let's move on and see. So the basic growth driver for the robotics industry is actually that the computational power is really constantly growing. And if you see today, there's a bit of noise on the computer. Yeah, thank you. So if you see today, the computational power is something like comparable to the brain of a mouse. That's what you can buy for $1,000. And this makes our robots already quite sophisticated, because they are able to understand the environment and the context they're in, and actually behave relatively intelligent. But if you just look ahead just a little bit and move forward to 2023, you will see that the computational power for $1,000, you can now buy a processor that computes at the speed of a human brain. Think about it. This will move the robotics industry very dramatically, because you will have very advanced systems that can perceive the environment, make very advanced decisions, and you will also be able to make affordable robots at that price. And you can even move it further ahead out in the future. And by 2049, the computational power of $1,000 of value will be the same as the entire human race, all combined in one processor. That will be a dramatic change going forward now. So think about it. And what I want to show you is that, first, let me say, some people have said that maybe this exponential development cannot continue, but actually there are also other predictions saying that it can indeed continue and maybe even accelerate further. One example here is a nanotube circuit, and these nanostructures. With that, you are able to, in 1 cubic inch, to have a computational power which is 1 million times bigger than the human brain. So if you are able to produce this in something like 8-10 years from now and transform them into processing units in our computers, you will have a giant leap forward in processing power. And moving on to the next, and here I think we need the next video. Yeah, so one of the implications of all this computational power is that we will see a range of very advanced sensors. So what we show here in the video is already something very simple, and you can buy it at around €100. one guy standing in front of a camera, and the camera is actually detecting his body movement, his arms, his legs, his head, everything he's doing, and is able to tell the computer or the robot what that person is actually doing. And let's move on to the next slide and the next video as well. Other type of very advanced sensors is basically, let me see here. Yeah, so this is a facial sensor for facial recognition and actually detecting the mood. So again, at around €100, you can buy a sensor that can detect the mood that people are in. So here also object detection, identifying objects, identifying where to grasp such objects. This is a technology now moving forward quite fast, and you also see a range of very versatile grippers in the market. And I think the last one, and please show the next video. In the last one, I really show you that manipulators are coming now at a very low cost, like €1,000. You can buy a manipulator, but also the models that robots have, they are able to replicate and show to you very detailed understanding of the world around them. In this case, it's just a robot painting a face of a person that it has seen. So yeah, you can see it's very accurate, and we will not have time to see it all, but robots can replicate the world very accurately. Another field which is moving forward very fast, and please move to the next video, please. Yeah, so artificial intelligence connected to robots is something we see move forward very fast. In this case, we're talking about robots that are able to perceive the environment, combine all these advanced sensor inputs, understand the environment, understand the context it's in, and also do reasoning about alternative ways of solving problems or move to different steps, and then executing those actions, and again monitor what happens and learn from that. So these are all very critical aspects for these robotic systems, and they're all coming with computational power and advanced sensors. Another feature for these kind of robots that we're building today is that they can now learn from experience. This means that the program in the robot is built in such a way that the robot can explore a little bit. They can make an action, and then they watch what is happening, or they ask a user, or they are looking and seeing what is happening, or they have an interaction with a person, and based on the feedback they can learn and adapt and optimize. And I think through the earlier presentation today we saw some examples of that. And this is also something that comes with computational power, that you're actually able to do that. And I think also a final thing which is very forward moving is that when we as humans learn from each other, we show to each other and we explain how to do things like cooking, for example, and it takes a long time and is quite slow. But robots are actually able to learn from each other in a digital way and doing it super fast. So if one robot learns how to cook an omelette, it can upload all that knowledge to the World Wide Web for robots, which is already built. It's not something to be built, it is already built. And other robots that are going to make an omelette can actually download all that knowledge, adapt it to its own body physiology, and very quickly take over all the knowledge that has been learned. In this way, you can also think about robots in a different way. Normally, you see a robot and you think about it as one robot, as one physical entity with one, like a person or something like that. But in the future, you should think more about a robot as one physical example, but with a shared brain in the cloud. All the robots will, at some level, connect and share a brain, because they can learn from each other. And here there are some critical questions also related to AI and where are the limits. But all these features that we see are actually one of the reasons why we see robots are moving fast, very with high speed. So advanced sensors, AI, learning by experience, and learning by sharing, these cloud robotic solutions are actually some of the reasons why we're moving forward very fast. And let's take a look a little bit at the market and how the market is moving. So you see here that all of the market segments that the robots are in, like even industry, but also military, commercial, and personal, and so on, they're all growing at a very rapid pace. And even if you go in and, let me see, even if you go in and, yeah, you see the same numbers here, but on a different kind of curve, but you see especially the service robots, personal robots, it's growing a lot. But even the most mature area, which is manufacturing, which is what you see on this slide, is actually growing quite rapidly, something like 16% a year, and that's a lot. If you look into the manufacturing area, just to give you an example and a basic understanding, you see that the automotive segment in the manufacturing space is actually the driver for all the manufacturing robots. So these are the pillars in the presentation, the high ones here, blue, green, orange, and so on, the high pillars. And all the other segments in manufacturing, there are very, very little robots there. So something like 90% of all manufacturing companies, they do not have a robot. This is the same or even worse in healthcare. Like 98% of all hospitals use almost zero robots. Maybe they have one Da Vinci surgery robot, but basically they have very, very little. So the era of the robotics industry is in front of us, not behind us, and that is a very important message. Taking a look at the next, this is the projection of the market for mobile robots, for internal logistics, for example, in hospitals. You see very rapid growth curves. And even this is a little bit old, but I know it has increased since then. But this is the biggest, one of the biggest robot companies in the world, Intuitive Surgical from the United States, making the Da Vinci surgery robot. You see the number of installed robots is growing very rapidly. So all of this is, I think, also again showing the Odense community, basically building up 120 companies in something like. Basically, all of them have been created in the last 15 years, and that shows the growth, the tremendous growth that we see in this robotics industry. And also some very respected people have been out saying a lot about the robotics industry. If you take Bill Gates, he has made an early announcement saying that there will be robots in every home, and we are actually on our way on that. The United Nations, they did a survey and came out with a conclusion saying that the robotics industry in this century will be bigger and have a bigger impact on economy and society than the automotive industry did in the last century. And also think maybe as a final remark on these disruptions, I think McKinsey did a study in 9 countries, including Denmark recently, showing that many jobs can be to some extent automated. Very few jobs can be fully automated, but many jobs include a lot of the tasks in a given job can be automated. So basically we're talking about that 50 jobs or job activities will be automated and removed from human work within 20 years. But all the research that has been done over the last years showing how the workplace changes shows that more jobs are created than are actually automated. And one example is also that today there are more jobs and working hours out there in the world today than ever before in history. So that's a good piece of news. The downside is that the character of these jobs changes. It requires higher and higher skill level. So educational programs for all is really a political topic that everyone should look at. So I think we will move on and to the second part of my presentation, basically showing you some of the robots that we have been working with for some time. and that have a direct relationship or impact in the healthcare industry. So let's move on to the next slide, or the next video, please. This is an example from, we're not showing you any robots here, but we're showing you some machines from the cleaning industry. Nilfisk is a Danish company. It's the biggest producer of professional cleaning equipment in the world. And Blue Ocean Robotics and Nilfisk are strategic partners. We work together through what we call a RoBX partnership program. Through this program, Blue Ocean Robotics is designing, developing new robots to come into the cleaning industry, including healthcare, which is a big market segment. So we're taking lead on that, on design and development of the robots. Nilfisk is taking responsibility on production, sales, service, and so on. Okay, let's take the next slide and next video. So here we're showing you an example. To the right, you're seeing a robot with UV light on the top, moving around inside a patient room in the hospital, killing all bacteria in 10 minutes, 99.9% of all bacteria in 10 minutes. And to the left, you saw a lady cleaning. And the robot is made as an assistant in the sense that she is doing the cleaning and removing all the visible things that she can see. At the same time, she has told the robot when she finishes her cleaning, and then the robot will wait outside the patient room. And then when she finished, the robot will move in. She will start the robot. 10 minutes after, 99.9% of all bacteria will be killed. By doing this every time you do the cleaning of the patient room, you are able to reduce the infection rate. And this is a very important thing. 150,000 people in Europe go to the hospital where they get an infection and end up dying because of that. 150,000 people. 10 billion euro are spent every year trying to prevent people from getting an infection. And I didn't even count the amounts of money that are spent on trying or on treating people that get these infections. So it is actually a very severe problem. Together with the university hospital, we developed this robot, and it is actually going into the market just these days. The first customers are actually starting up with it just here before the Christmas. Okay, let's take the next slide. Here we have another type of robot. You know that lifting people in and out of the bed and to the bathroom and so on requires today a lift which is fixed at the ceiling in the patient rooms. What we have done here, again, together with a super hospital, a university hospital, is to build a mobile robot. We call it multi-tower. It can navigate and it can widen and increase also its height. And it means that it can actually pick up a person from a bed. In many cases, the patient can actually get up into the robot by itself. Then the robot can get small and it can move into the bathroom and so on. But you can also use it as a rehabilitating device, because let's say you have a hip surgery, then you can walk with this, and the robot will take maybe something like 20 kilograms or so, and so you are assisted in that way. This is being developed right now, and yes, let's take the next one. This is the surgery. I think you're already showing this. Yeah. So in this case, we are making a robot for holding a camera during a laparoscopy surgery. Normally, today, you have one experienced doctor doing the surgery. He's using his two hands to hold instruments that are actually doing the surgery. And then you normally have a young doctor holding the camera. And he actually hates this job, right? He spent 5 years at university, 3 years in the clinic, and now he's holding a camera for 2 or 3 hours during a surgery for the elderly guy, and basically just adjusting the camera, like zooming out, moving it to the right and left once in a while. But what we've done is to make a robot that holds the camera, and when the doctor moves his eyes towards the side of the screen that he's looking at, the robot is tracking this, and the robot is moving the camera accordingly. So in this way, you can take out one doctor from the surgery and you can actually make the surgery shorter. So this is one example, and we are developing this right now. Okay, let's take the next one. In this case, we're working together with an American partner on telepresence robots. This means that this, I apologize, this is not from healthcare, this is from manufacturing in this video. But basically, it's all about being able to remotely being present. And we have installed a lot of these units. We are delivering something like 200 or 300 every year. And the healthcare sector is very big, like nursing homes, relatives visiting their parents, or in hospitals where experienced doctors connect on the robot, go and talk to a patient. And these kind of activities are really taking place there. Okay, and let's move to the next. Yeah, and in this case, you see a simple logistic robot. Even though they are very mature, that you don't see them that much in the hospitals in Europe these days, but they will come in the future. They can drive by the elevators themselves. They can open doors. They can navigate from any point A to any point B in the hospital. You can have a fixed wagon attached to it, or you can lift up a wagon like this. And there are many systems like that, quite mature. And every hospital and so on should really focus on getting these robots in. Let's move to the next, please. Here I'm showing a video of prosthesis. We are working with a company called Autos. This prosthesis is not from this company, I must say, but simply just showing that we're working on prosthesis, like was also one of the topics in the first talk today. And this is also an area that grows a lot. And please, let's take the next one. Drones is now also coming into the healthcare area. And so here it's a case where you see a robot moving with a defibrillator if we have heart patients that have fallen and you have a heart disease and so on. So this is all very important to get there very quickly, and the drones are able to do that. Yeah, just very briefly as a final thing, showing you that our RobiX partnership model is where we have teamed up. We have today more than 22 such partnerships. And basically, we have this inspiration and roadmap where we basically introduce the technology to our partner and make them understand the potential in the robot design and robot develop. We take a lead on designing and developing the robots. And when we go to market or scale up, that is on our partner side. They do production, they do the scale up in the market. And today, Blue Ocean Robotics, we started 5 years ago. Today we are 110 people, and we are based in quite many countries. So it's been quite a success, and I think we are also an example of this growing industry and the huge potential that you see in this industry. Okay, thank you very much for your attention.
Yeah, thank you very much, Klaus. I did not see Austria on the map, so no collaboration with Austrian organizations or companies as of yet.
We are working on it.
Okay. Well, we do a brief Q&A before then we also invite my Swiss colleagues over in a little while. But one of the questions that we received, and I think you partly addressed it already in your presentation, but maybe you can also put a little bit of a different spin on it. So the question reads, would you describe the healthcare sector as a fast or a slow adopter of robotics? And if I may add, maybe, do you see an increase in momentum currently?
I agree. It's a slow-moving sector because they're very conservative, and the way they purchase robots is very deorganized. I would say it's decentralized. So it means that you can have one hospital. They may have 20 of your robots very successful, but the neighbor hospital 20 kilometers away, they're very skeptical, even though the colleagues have very great success. So the penetration into that sector is very slow. And of course, for some type of robots, you have a very tough requirements on approvals, like with the laparoscopy surgery robot, it's very tough on approvals. I think the potential is huge in the healthcare sector. So there's a lot of opportunities, but you have to be in your budgeting or investment planning, you have to be just as conservative as the industry is, because you're not going to spend half a year on sales. You're going to spend 3 years before sales starts looking interesting.
Mm-hmm. Thank you. Yeah, you did mention already the super hospitals in Denmark, which is actually an expression for a large modernization that is happening at the moment with you have very big units being put in place, and they often present themselves or pride themselves as being a trendsetter. Do you see a lot of robotics being installed there, or maybe put differently, are they ready for a robotized future in healthcare?
It's a little bit of a mix. They started up, it's a 5.5 billion euro investment that the Danish government is doing in 5 super hospitals. They're becoming very modern and with a lot of new technology. So in a certain way, they've already paved the way for robots to go in. And we are, all the robotics companies working with healthcare robots are in a dialogue with them. But at the same time, they are also, they are not really taking the latest new technologies into account. They are kind of 10 years behind. So they're still talking about, should we have wires in the floor when we install logistic robots? And we're like, no, we stopped that at least 10 years ago. Don't think about it. So they are a little bit slow moving, and you see it even in these big hospitals. But of course, the opportunity is great because they invest so much in this.
Mm-hmm. Yeah.
If I take an example, the multi-tower robot, we have already a contract on 140 of these robots for 1 super hospital, which is, and it's not even built. The hospital is not even built. They've already ordered 140. All we have to do is to develop it such that it meets the requirements. So this is a good case, of course.
Mm-hmm. Yeah, thank you. So you being part of the Odense ecosystem, robotics ecosystem, what are the main drivers? How come it developed so fast? Is it the demand, or what other drivers are behind it?
So my background is that I started in robotics here in Odense in 1988. At that time, the Odense Steel Shipyard entered into a collaboration with Odense University, or University of Southern Denmark, which is the name today. And this was the beginning in 1988, so next year is 30 years ago. In the beginning was mainly industrial and welding and these kind of things. And basically the shipyard had some problems around year 2000, so everything died here almost. So in 2002 we restarted everything, building a new cluster, a robo cluster. And we built that up and started looking into other areas, other industries. And we got a lot of public funded projects, and we got a lot of good researchers and students on board. That was really good. For example, in one project we had 3 students working with robots in food industry, and we convinced them to start a company that became Universal Robots. And we made a great robot, but the real driver for the success was that other industry people with a lot of success from other industries, they came into the robotics industry. And the first guy was Enrico, the CEO, the former CEO of Universal Robots. He came in and took a look at this and said, listen guys, don't spend all your time on development, you need to sell. And then he transformed Universal Robots completely. So it was not a nerdy business, it was actually a business that was profitable. So I think the merger between robotics guys and industry guys from other sectors that have already a success and a track record, that created that success here. And if I look into the community here in Odense today, you have this mix of robotics people and business people and investors. And these investments are just increasing all the time. And I think just this year we started 20 more companies in Odense, in the city alone. Mm-hmm. So it's really good here. Yeah.
Yeah, thank you. And of course, very interesting for Austrian audience, how can Austrian companies actually tap into the Danish robotics experience? What's the potential for collaboration and cooperation here?
So there's a really good opportunity, and if you see the picture of all the 120, you see actually that maybe 30 or 40 of them are actually companies from abroad that have established themselves here in Odense. So the Odense Robotics, that organization is there to help. It takes 1 day to start up a company. You get an introduction to the hub right away. You can have a small office locally positioned close to university, close to all the rest of us. And they have these, for example, we just recently had an investment evening. 200 investors showed up, more than 200 investors showed up. More than 50 cases were pitched. And I think more than half of them are funded now. That's just 2 weeks ago. So, and you get access to all of that if you join the community here. So I think we are proud of what we're doing, and I think we can certainly compete with both Tokio and Zürich.
Thank you very much, Klaus, for backing me up on that. So on this positive note, let's have a quick look at our schedule yet again. It's actually now time for Q&A. So I would like to invite my colleagues in Switzerland to join us here in the webinar. Unfortunately, as mentioned, Japan cannot be with us. Not because it's late and they left the office, but because of technical difficulties, which of course should not happen in a robotics webinar of all places, but well, that's how it is. Well, yeah, welcome back. I will start with the first question to the plenum here, which is the doctorless hospital, science fiction or reality of the future, will the human touch stay relevant?
Well, I think there's always this fear that advancement take jobs away. They will take jobs away and they will create new jobs. And I don't think that the new jobs are about touching. I think they open our idea of medicine. We will find new diseases through algorithms. We will get more to know. We will have more treatments. But I think that the doctor, in the complexity of his thoughts, will not be replaced by a robot. The example is, you showed all these machines which are used. The machines are very restricted in their abilities, and the interaction with the human, and I don't mean interaction by touching, but getting to know the unpredictable human, and the human is unpredictable. This is so complex, and even if you show how intelligent as the machines increases, I don't think that they will be able, and I think they will bring new tools to the doctors to understand more about the human, but it still has to be brought together by one person. Like we have nowadays, we have very good advancements in medicine. We can draw blood, get a lot of information of it. We can take MRI, but still it has to be brought together by the doctor, and I don't think you can replace that by an algorithm. Yeah.
I would like to comment also. I fully agree on that. We're working together with one Danish hospital, and the medical director there, he has an interesting background because he started up with having an engineering background. So he knows about robotics and AI and stuff, and then he became a doctor, and now he's the CEO, medical CEO for 4 hospitals in Denmark. We have been working together for many years, and at one point in time he called me and we talked about things, and then in the end he said to me, he has been doing a survey of all the different jobs that his doctors and nurses are doing in the hospital. And then he said, I'm pretty sure that 80% of all the time they spend today can be automated in the next 10 years or so. Something like 80%. His conclusion was based on the fact that many jobs and activities they do is basically measuring and then diagnosing and then prescribing how to do a treatment. And this kind of doing this will be more easily automated because you have the powerful sensors, and you can also diagnose very efficiently. And then even with systems like the ones you're working on, I think we are moving towards maybe not 10 years. I think he's a little bit optimistic, but let's say 10 or 15 years, maybe 70–80% of all the jobs to some extent will maybe not be automated, but semi-automated, as you also suggest. So I think I agree very much on this conclusion, but I think the percentage of the amount of work that can be automated is actually quite high when you do that analysis.
Mm-hmm. Thank you. Yeah.
Then the question is the remaining 20%. And I think the machines will come to a limit, and it will not be endlessly exponential. These 20% will remain in human hand. And then when you imagine the more information we get through all this artificial intelligence, there are, as I said, more diseases and so on. People will live longer. So I think it will be then the total mass will be more of work.
Yeah, I agree on that, and I think the type of work doctors will do and nurses will shift a little bit from this, maybe a little bit routine-based, more into more development or more research-oriented. So I think I'm fully aligned on what you say, and it's not something where you suddenly have a 100% automated hospital. That would not happen.
Thank you. Yeah. Another question we received, which robot technologies will, in your opinion, be most disruptive in the healthcare sector in the near future, and which healthcare areas are most affected or promising? It was mentioned logistics only, or I mean, we saw rehabilitation before. What's your opinion on this?
Should I start?
Yes, yeah. Sorry, Klaus, please start. Yeah.
I think two areas will certainly change a lot. One is logistics, because logistics is very mature and you see very little of it out there. And if you ask a hospital today, on average, they spend 30% of all their cost is actually logistics. In one end of the hospital, you have very big logistic tasks like moving with pallets, then you have moving with wagons, then you have moving of boxes, and then finally you move water to the patient. All of this is logistics. They spend 30% of all their cost on logistics, and these technologies are very well developed. So here we will see over the next 5-10 years a huge change, and also releasing a lot of cost for the hospital. The other area is remote presence. You will see, for example, scanning hearts, scanning pregnant women, scanning knees, and so on. You will see a trend coming in more and more that this is done remotely, so the doctor will control the device, being with the patient, but not being physically there. I think this is more and more something that will come. This is also very mature. It's almost like a physical app on the net in the cloud. So I think that will also come. And then I agree, everything related to rehab will also move, but I think that will happen a little bit slower.
Mm-hmm. Thank you. Dr. Klambert?
I have nothing to add. For me, that is also interesting, I must say, this idea. Yeah.
Mm-hmm. All right, thank you. Then robot technologies do not come so cheap, and they require substantial investments. And the question being posed was, how does an SME actually deal with it? Because not only financially, but also human resource-wise, can an SME, or also from a hospital perspective, a smaller hospital or a patient clinic, afford these types of technologies? Maybe Dr. Klamroth maybe would like to elaborate.
Oh, I think I'm the wrong partner to answer that, but that was a question I also had, that we know that from the computers how difficult it is for the user to have a device which is really user-friendly, and we need a lot of support for that. And I wonder how long it needs until these machines are really, really cost-effective in the hospitals. Why it is more about research, and if we are not far away from that.
Mm-hmm. So Klaus?
I think you see a whole wide spectrum of performance and prices of robots. If you take the smallest logistic robots, you can have these for 500 to 700 euro per month, total cost, including maintenance, service, everything. 500 to 700 euros. These robots, they work 20 hours a day, 7 days a week. You don't get many employees to do that. So of course they will be here. They're very low cost compared to what they do. Even though they only move at half the speed of a human, they're highly efficient. One robot do the same work as 5 people over a week. So that's just the measurements we've done. But if you take in the other end of the scale, like exoskeleton, very promising, but still complex and still quite expensive. So, and that's also why it's moving maybe slowly, but it will come. It will get more and more cheap. And just an example, over the last, again back to the logistic robots, over the last 3 years, one logistic robot that we've been working with has reduced price from $140,000 to $60,000. That's one big one, but that's just to indicate how that price actually changed a lot. That's more than 50. It's almost 60% of reduction in 3 years, and this is a trend that is happening all the time. If you see today, you're using normally 2 laser scanners at around 3,000 or 4,000 euro on such a robot on a basic cost. You will be able to use 3D cameras at around 1,000 euro in the future to navigate. I'm talking about 2 or 3 years. But then when 5G technology comes in, you can use one antenna at €1, and you can position yourself 0.5 centimeter in every building in the world or in every place in the world. So this kind of change with the cost will come, and it will dramatically change the access to these technologies. Very important. Yeah.
Mm-hmm. Okay, thank you. There's a question from my side, I think actually directed to Klaus. So how can end users, and by this I don't mean patients, but for logistics robots and so forth, I'm thinking of the hospital, how can staff be involved in the development of these devices?
I think for the type of logistic robot that we've been developing, the hospital staff and also patients play an important role. So basically what you want is to enable the nurse or the doctor to spend as much time as they possibly can with the patients, because this is where the value happens. So you want, on the logistics side, you want the robot to fetch and bring stuff, and you want it to be very easy to take things out of the robot. So we're even trying to make robots that can bring things directly to the patient, and they can take things out of the robot themselves, so the nurse doesn't even have to take out the thing to the patient. But this last 2 meters of delivery is the most difficult. But I think there's a huge opportunity in automating these kind of things.
Mm-hmm. Dr. Klammer, do you have anything to add here?
No, I don't have.
I probably would have another question to Klaus, because it seems that Odense is quite advanced in the usage of robots in the health system. Klaus, would you be able to give an advice to the public health system people, decision makers? What advice could you give? What measurements or what measures the public health system should implement in order to advance the usage of robots in the health system? Is there any? Because in Austria, for instance, the hospitals are mainly under under the umbrella of the public health regulators. And there is sometimes a sort of a resistance towards adoption of new technologies in the public health system. But how can we enforce the implementation of robotic systems in the health sectors? What did Odense do in order to be successful in that field?
Well, I'm not sure I know all the ingredients, but I know that one of the things we started up with back in 2002, when we kind of reinitiated our cluster, we started promoting things a lot in the press. We started engaging labor unions. We started engaging public organizations in discussing what could be the future of robotics inside their industry. So over a long time, I think they gradually matured the ideas and the understanding. And then when you start up, it's always very important to find, this one extremely enthusiastic doctor at the hospital who really takes this upon him as his project, and starting up with 1 robot and then 2 and then 5 and so on. I think we've never sold like 20 robots to a first-time customer. That has never happened, actually. We have one customer, we sold one robot, then one more, and then they had 8, and now they bought 50. So you have to grow it step by step. So it's not just the hospital, it's also us as companies that are providing this. I would be extremely nervous if a new customer calls us and say, we need 50 robots, can you provide it? I'll be, let's start with 1 or 2, let's make it work and let's make it grow, because you never just install robots. You have people around these robots all the time. And the people need to be very enthusiastic about the robots and work with them and control them and do surveillance. I mean, we do 24/7 surveillance of all our mobile robots, and they have to play together with the hospital people. So do it gradually, but find these very enthusiastic people. Maybe have some funding opportunities so you can start up pilot projects, but with a clear message saying that pilot projects should prove themselves and become large-scale implementations across a wide range of hospitals, and have the funding for that as well. I think that would be a good program. That's where we may be missing a little bit in Denmark. We're very good at these pilots. We're very good at the first 5 robots, but then there's no structure going across all the hospitals, so you can implement in every place. There's no mechanism for that. So it's a fight every time you meet a new hospital. Maybe you don't have to make the same mistake in your place.
So the message is, make sure that we all overcome the fear which is somehow still attached to the robotic revolution, and to point out more the opportunities which bring the robots along. And I think that's also I
think it's more, I think you can't say the user is frightened and the user is reluctant. The device must be good enough, then that will not happen. And I think that the usability is a very important point, because we are all keen in technology, we are all curious, and also the users are. But when the devices are difficult to use, they will not be accepted.
Okay.
So I received a question specifically for Switzerland, because we elaborated on the cluster and the environment in Odense, but the participant would like to know, so a cluster or the right environment network is really important to get started and to move on. What is the experience here in Switzerland? Also working together from your work itself, Dr. Klamroth, but also working together with research companies and hospitals, and what has been done in Zürich.
Yeah, that is a very important point, and I think the ETH is becoming very active in this. There are always collaborations that also startups are now very much supported in their development, and they don't get only financial help, but they get also information, because often these startups are scientists and they don't know so much about business, and this is becoming more and more connected. So the ETH is supporting this. Then we have also financial support for the personalized health technology, that now there are grants specifically for this in a large range. And as I said, we work together with the hospitals. I think that is an advantage. Switzerland is a small country. It's all very condensed. We talk now all the time about Zürich, but we have also Lausanne, where the EPFL and other universities very successful. And we have this very closeness of everything, that hospitals and engineers and everybody is really together. And I think that is a very important point. Whenever you invent something, that you have this network of information from different groups, this interdisciplinarity, and that you always search from the beginning the user. But it's not technology driven.
But Verena, you actually told me also that there is a need of, especially in your field, in the rehabilitation, that that the university and the robotic development structures find new partners by also abroad, because there are not enough test cells in Switzerland, and probably that would be also an opportunity for Austrian rehabilitation clinics to cooperate with developers here, and have the here developed robots tested also on site in Austria.
So when we talk about robots in medicine, which really interact with the human, of course we have the artificial intelligence coming. We have simulation, we can simulate a lot, but still the gold standard is a clinical study. You must test it in people. You can't simulate it and calculate it only. And we need clinical partners a lot. Really are interesting in corporations to do the research in the clinics and try the devices with the users.
So basically, if one of the participants at the webinar today listens and has a good contact to clinical possible partners for clinical studies, please do not hesitate to contact us, or and we will link you up with you, Dr. Klamroth. Yes.
Yeah, well, thank you very much, Manfred, and I think this is true for also my colleagues in Japan and also, of course, for us here in Denmark. Please, if you have any questions after the webinar, need contacts and so forth, do not hesitate to contact us. This brings us already to the closing of our webinar, I should say. Thank you very much to all the speakers in Zürich, also in Tokio and in Odense, and also to my colleagues in the respective cities. Vielen Dank an die Zuhörer und Zuschauer. Danke, dass Sie so aktiv mit dabei waren, so lange mit dabei geblieben sind. Ihnen allen einen schönen Tag. Have a wonderful day and also a great Advent season. Thank you very much and see you next time around. Bye-bye.
Thank you for moderating everything. Thank you.